Okay, class, today we are going to be graphing polynomials. So we're going to review what a polynomial function. So a polynomial function essentially has a bunch of coefficients and x to some different powers. So where n is some real number exponent. So they are whole numbers, not fractions. And a sub n, the number out there, is called the leading coefficient. A sub 0, the one without a variable, is called the constant term, or the constant, and n, the largest exponent, is the degree of the polynomial. And we have some common names, like 0, it's a constant. If the degree is 1, it's linear, quadratic, cubic, quartic. Anything after that would just be like degree 5 polynomial or degree 6 polynomial. Okay, but you should recognize the names. So standard form, it's when it's written in descending order. So essentially you find the highest exponent and write that first. So we're going to write this in standard form. So we have the f of x is minus 3x to the fourth, the next decreasing exponent, and you keep going down until the constant term. So that would be standard form. The leading coefficient would be the first number in front of the term with the highest exponent, so it's negative 3. The constant term is the last one with no variable. It's 1. The degree is the highest exponent. Degree 4, the type, that would be the name. So if it's degree 4, it is a quartic. Okay, so those are just the terminology review. So the general shape of polynomials, essentially you're going to have a smooth curve with no sharp turns. So it shouldn't look like a V anywhere. It should just look like smooth curves, no sharp turns. Okay. As you draw from left to right, you don't lift your pencil, which is a sign of it being continuous. So no breaks like you had in a piecewise function. And then the end behavior of the graph, as it approaches infinity or negative infinity, is something that we're going to be talking about next, the end behavior. Okay, so here's how we're going to describe the end behavior. So the leading coefficient is positive and the degree is even. So these are the 4 cases. The degree is even and the leading coefficient is positive or negative, and the degree is odd and the leading coefficient is positive or negative. These are the 4 cases of the polynomials. So as x approaches infinity, so as x goes towards infinity, my function is going up. It approaches infinity. On the other hand, as x approaches negative infinity, my function here is also approaching infinity. Okay. And that's always the case when the degree is when the leading coefficient is positive and the degree is even. The leading coefficient is negative and the degree is even as x approaches infinity. So as x approaches infinity, my function approaches negative infinity. And then as x approaches negative infinity, the function also approaches negative infinity. Now the characteristics of them both, the degree being even, either they both point up or they both point down. Okay, so that's what you need to remember. Even, they both point in the same direction. If it's positive, they go up, positive direction. If it's negative, they both go down, negative direction. Okay, here the next case is when the degree is odd, the leading coefficient is positive. So notice for odd, they point in opposite direction in both cases for odd. Okay, so when the leading coefficient is positive, it's going up here on the right-hand side, positive right side. When the leading coefficient is negative on the right-hand side, it's going down. Similar to when it's even, they're both pointing down for negative. Okay, so as x approaches infinity, the function goes up. It approaches infinity. As x approaches negative infinity, so as x gets really small, my function is approaching negative infinity. They point in opposite direction. Okay. The last one, leading coefficient is negative and the degree is odd. Degree is odd, point in opposite direction. Degree is negative, on the right-hand side it's going down. So as x approaches infinity, the function is approaching negative infinity. as x approaches negative infinity. That way, my function goes up towards positive infinity. Okay, so it's always going to be one is positive, one is negative for the x terms. And then the f of x is the end behavior. Both up, both are positive. Both down, both are negative. Right up, down, left, positive, negative, and so on. Okay, so you do need to memorize these end behaviors for those 4 types of graph. Okay, some more terminology. The function f is degree n, so it has at most n x-intercepts, which are also known as zeros and roots. And in fact, if it is degree 5, it will have 5 roots, but it may not have 5 x-intercepts, because some of them may be complex. And there's at most n minus 1 turning points, or what's also called as relative extrema. And the relative extrema are the maximins. So if it is degree 5, it has at most 4 turning points. Okay, and if you think of a quadratic degree 2, it has at most 1 turning point. Okay, so the number of turning points is 1 less or more or less than the degree. Okay, so if you have a real number, a, so if a is a real number, x equal a is called the root of the function, or the solution to the function f of x equals 0. So when we said equals 0, you solved it. X minus a is the factor, and in fact, for the first 3, even if a is a complex number, a complex, it's also true. Okay, the last one, x-intercept, a0 is the x-intercept. This is only true if a is a real number, because if you have a complex root, like if you solved an equation and you get a complex number, something with an I in it, it's not an x-intercept, but it is a solution or a root. Okay, so here we're just going to fill in the table looking at the graph. Okay, so you need to look at this graph. You see they're pointing in opposite directions, so automatically you know the degree is odd. The right-hand side is pointed up, so you know the leading coefficient is positive. Okay, it crosses the x-axis 1, 2, 3 times, so there's 3 x-intercepts, so you know the degree will be at least 3. You can also look at the turning points, and there are 1, 2 turning points, so you know that the degree has to be at least 1 more than the number of turning points. Looking at the end behavior, one of these is positive infinity, the other one is negative infinity. So as x approaches positive infinity, the function is positive. As x approaches negative infinity, the function approaches negative infinity. Next one, they both point in the same direction, which is an indication of even. The right-hand side is up, leading coefficient is positive. The number of x-intercepts, 1, 2, 3 times it crosses, so there's 3 x-intercepts. So the degree will be at least 3, but if you look at the number of turning points, you have 1, 2, 3, 4, 5 turning points here. So you know the degree has to be at least 6. Okay, that's because there's 5 turning points. Okay, so let's fill in the table. As x approaches infinity, the function goes to positive infinity. As x approaches negative infinity, your function approaches positive infinity as well. Okay, last example. They both are pointing in the same direction, so it's even. They're both pointing downward, namely the right-hand side is pointing down, so it's negative. Number of x-intercepts, I see it crossing the x-axis once. The degree will be at least, so let's count the number of turning points. There are 3 turning points, so the degree has to be at least 4. Okay. As x approaches infinity, so as x gets big, the function goes down to negative infinity. As x approaches negative infinity, the function also goes down and approaches negative infinity. Okay, let's move on. So here, what could be the equation of the graph shown? So here I'm assuming that the scale excuse me, is 1s, and we are just going to look at this graph. So I see an x-intercept here, here, and here. So I have 3 x-intercepts. So this x-intercept is -5, -1, and 2. So if you have an x-intercept of 2, it comes from, if I bring 2 equal to the other side, the factor x minus 2. So this is the factor. This is the root, or the x-intercept. So I have factors x minus 2, x plus 1, and x plus 5. And it's the opposite sign, because if you think of it, if you take the factor x minus 2 and set it equal to 0, and then you go up to get x equals 2 as your root. So we have f of x is x minus 2 times x plus 1 times x plus 5. If I were to multiply this all out, I would get an x cubed, and if you look at the number of turning points, which is 2, we know that the degree has to be greater than or equal to 3. We also know that on the right hand side it goes up, and the left hand side it goes down, so we know that the degree has to be odd, and this would be an x cubed, which is an odd degree. On the right hand side is going up, so that tells me that the lead coefficient is positive. So I know I have to have some positive number. Any positive number there really would work. So this would be an adequate solution. It could have been 2 over there, or 5, or any positive number. And that would be 1 possible. And you don't have to multiply it out. Okay, so here we are going to graph the polynomial. So we need to look at the leading coefficient. So the leading coefficient is -1. The degree is the largest exponent, which is 3. So we know that when the leading coefficient is negative and the degree is odd, they point in opposite direction. Leading coefficient is negative. On the right hand side it goes down, on the left hand side it goes up, and it does something in the middle. Okay, but essentially on the left it goes up, right it goes down. Max number of turns, so it's degree 3, so the max number of turns is 2. So the factors, so we take our function and we factor it. So my f of x, I'm going to pull out the GCF, which is -x, and I'm left with x squared minus 3x minus 4. And I'm just going to factor it to find all of my x-intercepts. So use the box method and factor it, or whatever technique you know, but I factored it in my head. So those are my factors. Okay, those are the factors. So my x-intercepts are x equals 0, 4, and -1. So from my 3 factors, I got my 3 x-intercepts. So I'm going to plot those 0, 4, and -1. And I have my end behavior. On the left it goes up, and on the right it goes down. So I know that it's going up, and I know that it's going down. And I need to connect the dots. Okay, so in class we're going to do an investigation that gives us a little more detail, but essentially I know it's going to cross here and go up somehow and here. So it's a sketch. Notice there's no values marked on the y-axis, but on the x-axis I do know those. Okay, so I know my end behavior. Okay, and the end behavior I know because the leading coefficient was negative and the degree was odd. So looking back at the table, I know it goes here, and I know it crosses the x-axis only at those 3 places. It can't cross the x-axis anywhere else, because if it crossed anywhere else, then it would be an additional x-intercept. But these are the only 3 places it can cross the x-axis, because those are the 3 x-intercepts. So there you have it. That is how we sketch polynomials, and in class we will do an investigation looking at whether it's going to cross the x-axis or just come down and touch it and come back up again. So you have a wonderful evening, and I'll see you in class.